Hey, Harsh here. Today we are going to talk about replication strategies. Before we argue how to copy data, let's remember why we do it. In a distributed system, we replicate to survive. If a node crashes, and it will, replication ensures the service stays up. But we also replicate for performance, like keeping data geographically closer to a user to reduce load times, or separating read traffic from write traffic. The mechanism you choose, sync or async, dictates how well you achieve these goals and what price you pay for them. Let's start with synchronous replication. Imagine you are transferring $1 million. You want to be absolutely sure that the money is recorded safely. In synchronous replication, the primary server does not tell the client success until replica confirms it has also written the data. It's atomic. If primary crashes immediately after the write, you lose nothing because the replica has an exact copy. This gives us an RPO, recovery point objective, of 0, but safety isn't free. The cost is latency. Your write speed is now determined by your slowest replica. If your replica is 50 milliseconds away, every single write now takes at least 50 milliseconds. This is why synchronous replication is usually limited to distances under 300 kilometers. Furthermore, you have a new risk. If your synchronous replica crashes or the network fails, your primary database might stop accepting writes entirely to prevent data divergence. You are trading availability for consistency. Now let's look at asynchronous replication. Here, the primary commits the write and tells the client success immediately. It doesn't wait for the replica. It sends the data later, maybe a millisecond later, maybe a second later. This is fire and forget. The massive advantage here is throughput. Your application feels lightning fast because it isn't waiting on a network round trip to a different city. But if your primary server smokes and catches fire before it transmits the last batch of updates to the replica, the data is gone. In a failover scenario, your replica promotes to master, but it is missing the few last milliseconds or seconds of data. In high traffic scenarios, if the replica falls too far behind, the primary might even delete the transaction the replica needs, breaking the link entirely. You have to ask, can your business survive losing the last 2 seconds of the data? Is there a middle ground? Yes, semi-synchronous. In some implementations like MySQL or configured Postgres, the primary waits for an acknowledgement that the replica received the transaction in the memory, but not necessarily that it finished writing to the hard drive. This cuts down the latency significantly. Some systems also have adaptive. They try to be synchronous, but if the network lags too much, they temporarily switch to asynchronous so that your app doesn't freeze. But be careful though, during that fallback period, you are vulnerable to data loss. Modern distributed databases like CockroachDB use consensus algorithms. Instead of saying, wait for replica 2, they say, I have 5 replicas, wait until any 3 of them agree. This is Quorum. It solves the availability problem of asynchronous application. If one node is slow or down, the system ignores it and proceeds as soon as the majority responds. You get zero data loss, high availability, though you pay a latency cost compared to pure async. So what do you choose? If you're building a banking ledger or a healthcare system, you usually eat the latency cost and go synchronous. You cannot explain to a user why their deposit disappeared. But if you're doing a disaster recovery between New York and Tokyo, you must use asynchronous. The speed of light prohibits the synchronous replication over that distance without destroying the user experience. For high frequency trading or ATTEC, where every nanosecond counts, async is the only option. Hey, if this video helped you understand this topic, don't forget to like and subscribe. You can also drop your suggestions down in the comments about the improvements and the topics you would like me to cover next. Till then, thanks for watching and I will see you in the next one. Peace.